Classification of the collisions. So define the collision. We know that in the collisions the total energy will be always conserved, but the kinetic energy will be different. So what is the how many types of the collisions? So especially I am taking, there is a two types. Okay, so first one, so here the classification collisions on the basis, one is basis of direction, basis of direction of motion, direction of motion of colliding body, colliding body, right? So the classification, what is the first one? First case, basis of direction of the motion of colliding body. In the case 2, second case, on the basis of law of conservation of kinetic energy. Okay, the classification is mainly the two types. One is direction of the motion, depends on direction, depends on kinetic energy. So in the depends on direction, depends on direction, here I am taking, and depends on kinetic energy. Okay, in the depends on direction, so what is the how many types? In this one, two types. One is head on collision or one dimensional collision. Head on collisions or one dimensional collisions. And second one, oblique collision. Okay, so in the direction, okay, the basis of the direction of motion of the colliding bodies. So one is head on collision, another is oblique collision. In this kinetic energy is a collisions, elastic collision, elastic collision. Second one is inelastic collision. Okay, so it depends on kinetic energy. How many types of the collisions? Elastic and inelastic. So that is perfectly elastic and inelastic or semi-elastic collisions. So first one, in the head-on collisions. Okay, what is the head-on collision? Head-on collision or one-dimensional collision. So in the head-on collisions, I am taking two objects. A is one object, mass m, and B is another object, another mass m. Okay, so the both are moving particular direction. So this is the before collision. After collision, what happened? It is moving the same path. It is moving same path, that is the same direction. It is moving the same path or same direction. This is called head on collisions. So what is the head on collision? I am taking the two, A and B, A and B. So A is a one particle and B is another particle. Both are is having some masses colliding to each other before collision. Okay, this is a before collision. So after collision, what happened? It is moving the same direction. After collision, it is moving the same direction. That is the same straight line. That is same straight line. So this is collisions is called head-on collisions. And second one, oblique collisions. Okay, oblique collisions. So what is the oblique collision? These collisions in the not straight direction, particular direction. So this is A is one object, this is one B is the object. Here A is colliding at particular angle. Okay, at particular angle A is moving like this, the B is moving like this. Okay, the B is moving in the different direction. Actually this is a exactly straight direction. Here this is a impact. So what is the oblique collisions? When one object, A is the one object, is colliding with B with some angle, so what happened? This A and B particles is not moving in a same line, it is moving in a plane, so this is collisions is called oblique collision. Especially these two particles A and B is moving in a plane, so these collisions is called two-dimensional collisions. This collisions is called two-dimensional collisions. Otherwise, it is a three-dimensional collisions. 3-dimensional. So the both are A and B is not moving a straight line direction, it is a moving in a plane. So that is called a 2D collision, 2-dimensional collisions. Otherwise it is a 3-dimensional collision. So this is only depends on the direction. How many types? One is head-on collision, another is oblique collision. The both are moving in the same line, same straight line direction, that is called head-on layer of 1-dimensional collision. In the different directions is moving, that is called oblique collision. And next one depends on the kinetic energy. In this kinetic energy, how many types? One is elastic and inelastic. So here in the taking first one, so depends on kinetic energy, the first one perfectly elastic collision. In the perfectly elastic collision, both momentum plus kinetic energy remains constant. So what is the perfectly elastic collisions? So the before momentum, before kinetic energy, after collision, momentum and kinetic energy both are same. Here this is one object A and B, okay, and this is a before collision, and after collision it is a moving like this. Here after collisions, this is after collisions. So what is a perfectly elastic collisions? The before momentums, total momentum, and after momentum, before momentum pi, after momentum, both are equal, and the before the kinetic energy, after kinetic energy, both are equal. So this is collisions is called perfectly elastic collisions. Examples in this one, so the collision between atomic particles. What is the example? Atomic particles, collision between atomic particle, this is an example. And the second example, alpha particle with nucleus, so this is an example of perfectly elastic collision. And second one, inelastic collision. So in the inelastic collision, what happened? Their kinetic energy is not conserved. Their momentum P is conserved. So the collisions in which the kinetic energy is not conserved, but it is obeys to law of conservation of the momentum. So this type of collisions is called inelastic collisions. So in the inelastic collisions, here what is the example? The example is a 2 billiard balls. Okay, 2 billiard balls. Okay, some games we know that very well in the billiard balls. So the collision between 2 billiard balls, it's give the inelastic collisions. And 2 automobiles, suppose the car and bus, so the automobiles on a road collisions, it is also inelastic collision. Third one, another one in the special case, here perfectly inelastic collision, perfectly inelastic collision. So in the perfectly inelastic collision, in this collision, two colliding body strike. Here this is one object, this is another object, A and B both are colliding. Okay, so it is moving the common velocity. After collision, it is moving the common velocity. This collision is called perfectly inelastic. So this is a plastic collision. Sometimes this is called plastic collision. Inelastic, this is called semi-elastic. So what is a perfectly inelastic collision? If in a collision the two colliding bodies, this is A and B, two colliding bodies strike to each other, move with a common velocity. So this type of collisions is called perfectly inelastic. So for example, here bullet and block. Okay, so this is a one block system, block and bullet. Okay, so when bullet is fired, when the bullet is fired. So the collision between a bullet and a block of wood, it is a fire, the bullet remains embedded here, it is a penetrated in a wood. So this is the types of the collisions. This is a what is a classification. So one is, there is a two types. One is a basic direction of the motion of the colliding body, and then a law of the kinetic energy. One is head-on collision, oblique collisions, and elastic, inelastic, especially perfectly elastic, and inelastic or perfectly inelastic collisions. Very important. Elastic collision in the one dimensional. Elastic collisions in the one dimensional are perfectly elastic collision, head-on collision. Head-on collision is very very important here. Listen. So let us take one object. This is a one object. Their object mass m1. Okay, what is the mass of the object? m1 moving with velocity u1. Moving with velocity u1. And another object m2 moving with velocity u2. So this is a before collisions. Here before collisions. What is the mass? m1 mass. What is the initial velocity? u1 velocity. And what is the second object mass? m2 mass. What is the velocity? u2 velocity. It is moving particular direction. And after collision, okay, here after collision, what happened? So here this is a both are colliding to each other, m1 and m2. After collision, this is m1 particle moving with velocity v1 and the m2 particle moving with velocity v2. So before collision, their velocities u1 and u2. After collision, change the velocities. How much change the velocity? v1 and v2. So now I am apply law of conservation of linear momentum. First one, apply law of conservation of linear momentum. Law of conservation of linear momentum. I apply the law of conservation of the linear momentum. Okay, so here linear momentum. So what is the linear momentum? First you can apply before momentum before collision, and after collision. You can find the momentum before collision and after collision. So what is the before collision? Here we know that momentum formula, mass into velocity. I am taking this is one object. What is the momentum of first particle? m1 u1. This is a momentum is equal to plus second one particle m2 u2. This is a before momentum is equal to what is after? Mass m1 v1 plus m2 v2. So the before momentum is always equal to after collision. This is called law of conservation of the linear momentum. Here I am taking, so this is v1 is going to here and ut is going to here. So I will write m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Okay, here m1 common, m1 u1 minus v1 is equal to m2 v2 minus u2. So I am taking this is the equation number 1. First I am apply conservation of the linear momentum. Here second we apply conservation of the kinetic energy. Okay, because it is elastic energy, momentum and kinetic energy both are conserved. So here I am apply second one, kinetic energy, law of conservation of the kinetic energy. So what is the kinetic energy of this first particle? So 1 by 2 m1 u1 square formula. So this is a kinetic energy of the first particle, m1 particle moving with velocity u1. So that is 1 by 2 m1 u1 square. Second particle 1 by 2 m2 u2 square is equal to after collision 1 by 2 m1 v1 square and 1 by 2 m2 v2 square. So this is the apply the conservation of the kinetic energy. Here all are 1 by 2 1 by 2 1 by 2 1 by 2 cancel. Okay, so here I am taking m1 u1 square plus m2 u2 square is equal to m1 v1 square plus m2 v2 square. Same thing, the 1 is coming to here, 2 is going to here. So what happened in this one, here m1, I am taking m1 common in the previous case, u1 square minus v1 square is equal to m2 v2 square minus u2 square. So I am taking, this is the equation number 2. Okay, this is the equation number 1. m1 u1 minus v1 is equal to m2 v2 minus u2, and second equation m1 u1 square minus, so u1 square minus v1 square is equal to m2 v2 square minus u2 square. Now equation 2 by 1, equation 2 by equation 1, dividing equation 2 by equation 1. I am taking the equation 2, we know that very well, and equation 1. So here what is the equation 2? m1 u1 square v1 square is equal to m2 v2 square minus u2 square. Okay, by what is the equation 1? m1 u1 v1 is equal to by m1 v2 minus u2. m1 m1 cancel, m2 m2 cancel. Here I am taking a square minus b square. So what is the formula? Here I am taking, we know that a square minus b square is equal to a plus b into a minus b. This is the formula, a square minus b square. Apply. So a square minus b square you can apply. So that is u1 plus v1 into u1 minus v1 by u1 v1 is equal to, next same thing, v2 plus u2 into v2 minus u2 by v2 minus u2. So which term will be cancelled? u1 v1 minus u1 minus v1 and v2 minus u2. So what is the remaining terms here? So the remaining terms, u1 plus v1 is equal to v2 plus u2. Here this is a ut is coming to here, v1 is going to here, u1 minus u2 is equal to v2 minus v1, or u1 minus u2 is equal to minus v1 minus v2, v1 minus v2. So this is I am taking the equation number 3. So right, so what is your observation here? u1 minus u2 is equal to v1 minus v2. u1 and u2 is the velocities, so that is relative velocity. u1 minus u2 is equal to relative velocity, and here also relative velocity. So in the head-on collisions, the relative velocity, this is a relative velocity. Head-on collision, the relative velocity approaches before, approaches means coming towards, before collisions is equal to relative velocity of separation after collisions. What is your observation? The before collision relative velocity is equal to after relative velocity of the separation will be equal. Here I am taking, so what is our concentration? Find what is the v1 value, what is the v2 value. Calculate what is the v1 velocity after collision, what is the velocity, v1 velocity and v2 velocity. Here I am proved the first one, I am calculate v2 velocity. So for this purpose, equation 3, u1 minus u2 is equal to minus v1 minus v2. So or u1 minus u2 is equal to v2 minus v1. So this equation, what is the v1 value? v1 is equal to v2, here v2 plus u2 minus u1. Substitute. Okay, so this is the equation 1. So here this is a v1 is equal to v2 plus u2 minus 1. So substituting this equation v1 in the first equation. Okay, equation 1, substitute at what equation? This v1 value substitute in the equation 1. So that is m1 into u1 minus v1 unde akkada. So v1 means v2 plus u2 minus u1 is equal to m2 v2 minus u2. Okay, so therefore here m1 u1 minus m1 v2 minus m1 u2 minus of minus plus m1 u1 is equal to m2 v2 m2 u2. So here m1 u1 m1 u1. Okay, 2 m1 u1, clear, minus m1 u2 minus m1 v2 is equal to m2 v2 m2 u2. Now this m2 u2 is going to here and m1 v1 is going to here. Okay, so here I am writing 2 m1 u1 minus m1 u2 plus m2 u2, this is coming to here, and m2 v2 plus m1 v2. So in this one here 2 m1 u1 plus m2 minus m1 u2 common, and here m1 plus m2 v2 common. So this m1 plus m2 is dividing, is coming to here. So what happened, 2 m1 by m1 plus m2 u1 plus m2 minus m1 by m1 plus m2 u2 is equal to v2. So this is our final equation. So 2m1 m1 plus m2 u1 plus m2 minus m1 by m1 plus m2 u2 is equal to v2. This is a after collision their velocity of the second body. Next we can calculate v1 value. v1 v2 is over. Now we can calculate v1 value here. So we know that v2 is equal, from equation 3 v2 is equal to u1 plus v1 minus u2. Okay, so this v2 value substitute in equation 1, substitute in equation 1. So that is m1 u1 minus v1 is equal to m2, substitute, what is the v2 value, u1 plus v1 minus u2 minus u2. Okay, same thing here, m1 u1 minus m1 v1. So just you can multiply here, minus u2 and minus u2, I am taking directly m2 u1 plus m2 v1 minus u2 u2 2u2. So 2m2 u2, 2m2 u2, this 2m2 u2 is going to here. Okay, and this m2 u1 also going to here. What happened, m1 u1 minus m2 u1 plus 2m2 u2, this is going to here, is equal to m2 v1 plus m1, okay, m1 v1. So where u is common, u1 is common, m1 minus m2 plus 2m2 u2, m1 plus m2 v1 is common. So this is the m1 is coming to here. What happened, v1 is equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. So this is a v1. So after collision, okay, so please see that one is very easy. This is just multiplied m2 u1 m2 v1 and minus u2 minus 2 u2, just you can multiply these terms, two terms is going to here, one term is going to here. After is the dividing, this m1 plus m2 is the multiply with the v1, it is going to here, it is a dividing. So finally we can get to v1 is equal to m1 minus m2 by m1 plus m2 u1 to m2 m1 plus m2 u2. So this is a find in the v1 and v1 and v2. Some special cases is there. This is the special cases. Okay, so the number of special cases. First one, if m1 is equal to m2 is equal to m, both are same masses, both are same masses, what happened, their v1 is equal to u2 and v2 is equal to u1. Just substitute m1 is equal to m2 is equal to m. So the both are same masses, before collision, after collision, what happened? V1 is equal to u2, v2 is equal to u1. So that is two bodies are equal. The bodies simply exchange their velocity. The first velocity u1 is going to second particle, second velocity is going to first. Exchange of their velocity. This is the first case. And in the second case, u2 is equal to 0. u2 is equal to 0. That is the second body is rest. Second body is a rest. So in this case, there v1 and v2, what happen? m1 minus m2 by m1 plus m2 into u1. And what is the v2? 2 m1 u1 by m1 plus m2. Okay, so here in this case, what happened? So when u2 is equal to 0, the second body is equal to rest. Second body is equal to rest. What is the v1? This is a v1 equation and v2 equation. Suppose the both are same. In this case, m1 is equal to m2 is equal to m. What happened? v1 is equal to 0 and v2 is equal to u1. So in this case, colliding particle come to rest. Okay, come to a rest, and the other particles move with the original velocity u1. Both are same mass. Okay, the first one velocity is a stop, but in the second velocity is a moving with velocity u1. The different cases is there. Okay, and the third case also is very simple. Third case, here suppose the m2 is very greater than to m1. m2 is very greater than 2. Then what happened? v1 is equal to minus u1 and v2 is equal to 0. So the m2 is equal to very big ball, okay, lorry, and this is the m1 is equal to car. The car is colliding with a very big lorry. What happened? What is the velocity of this one? There is no velocity, but the car is moving in the opposite direction. The car is moving in the opposite direction. That is the v1 is equal to minus u1. Suppose here fourth case, there m1 is very greater than to m2. This is the bus. Okay, this is a bus. This is a very small car or scooter or bike. So this bus is colliding with the car or scooter. What happened? There v1 is equal to u1. v1 is equal to u1 and v2 is equal to 2u1. v2 is equal to 2u1. What happened? In the second one, the car is moving, is a double velocity of the buses. Double velocity of the buses. So this is a collisions in the one dimensional object or head on elastic perfectly collisions and some special cases. Coefficient of restitution. So what is small e? The coefficient of restitution. What is the small e? So we know that here two object, one is m1 and this is a m2. So at initial velocities we know that u1 and u2, and after collision their velocity v1 and v2. So what is the coefficient of restitution? E is equal to formula v2 minus v1 by u1 minus u2. E is equal to v2 minus v1 by u1. So what is meaning of v2 minus v1? Means relative velocity separation after collision. This is a relative velocity. We know that very well. The relative velocity is a before collision or after collision? After collision by here relative velocity before collision. Before collision. So what is your coefficient of restitution? The ratio of so before and after relative velocities. The here this is the after relative velocity, before relative. The ratio of their before and after velocity is called coefficient of restitution. So it is small e. What is the units of small e? There is no units. What is the units? There is no units. What is the dimensional formula? No dimensional formula. No units, no dimensional formulas. So small e is equal to no units. But in the perfectly elastic, okay, perfectly elastic collisions E is equal to 1. Perfectly elastic collision E is equal to 1. Perfectly inelastic collision. Perfectly inelastic collision E is equal to 0. So always the collisions between 0 and 1. Always the collision between 0 and 1. Suppose here one object, this is a one ball, here this is a one ground. Okay, so when a ball is instated particular height h1, it hit the ground, it rebounds particular height h2, rebounds particular height h2, one ball. So this is the one ball, here the ball is dropped very freely particular height h1, it is a rebound. So how much height after hitting the ground, it is reaches the particular height h2. So in this case E is equal to same there, v2 minus v1 by u1 minus u2 is equal to minus v1 by u1, because here v2 final velocity this case is equal to 0 and u2 also final height their velocity will be 0. So v1 is equal to rho to 2gh, general formula. Okay, so rho to so I am taking directly 2gh2 and u1 is equal to, here I am taking, this is a minus, and u1 is equal to under root of 2gh1 initial velocity. So you can taking the ratio, E is equal to minus v1 by u1, E is equal to minus v1 by u1. So what happened, the minus of minus plus 2gh2 by 2gh1 to root 2 all or everything inside is a cancel. So under root of h2 by h1 under root of, so this is also E is equal to under root of h2 by h1. So it is a determination of the coefficient of restitution. So find the coefficient of restitution between the two bodies of different materials. What is the formula? E is equal to under root of h2 by h1, or what is the time? E is equal to t2 by t1 or v2 by v1. This is all our coefficient of restitution formula. So this is a complete about of a collisions. Thank you one and all. So this is the end of the class. Work power energy, so the coefficient of the restitution. Thank you one and all.